Hey guys, Brian Schultz here with the Actually Tiny House Project, where we are exploring smart, simple, sustainable tiny house design and giving you some building tips along the way. Now, today what I want to talk about is the frame of this tiny house that we've been building for the last couple months here, because we made a lot of decisions both in the planning stage of this and the execution of the frame to make the house a little bit lighter and also a little bit more energy efficient. So what I want to do here is take you on a little tour of all the framing details for this tiny house, including some of the things that we do a little bit differently than other people, and especially things that we did that we wished we would have done differently and are going to do differently on the next tiny house build. Now, one thing I want to be really clear about is that this is not the epitome of how lightly you can frame a tiny house and still have it be strong. What this is more of a balanced approach between minimizing framing while at the same time not causing yourself a lot of difficulties during the rest of the construction process. All right, so let's start out by talking about space design here, because obviously how you design your tiny house is going to have a huge impact on how you're going to be able to frame your tiny house. Now, I don't want anything that I say in this video or any other video to be misconstrued as a judgment on other people's tiny house choices. I just like to do things as simply as possible so I can minimize my framing. And you can see that behind me here, this tiny house is as simple as it gets. It's 4 walls and 1 flat straight plane for the roof. I've got a window at either end, a window here and a door here, and that's it. And the reason that I chose this particular structure is because this is naturally going to be conducive to me framing this as minimally as possible so I can have as much room as possible in the walls for insulation. So before I dive into all the framing details here, I want to talk a little bit about window selection, because this is one of those decisions that you need to make during the planning process that affects your framing, which affects the overall thermal performance of your building. When you're thinking about windows and energy efficiency, it's not just the surface area of the glass that's going to leak heat out, it's also the framing around the perimeter of that. And the more small windows that you have, the more framing that you have transmitting heat to the outside of the building, and also proportionately smaller amounts of glass for the same amounts of frame. So even though a lot of small windows can give you an overall more balanced light, we decided to go with fewer large windows in here, so once again we could have as much space in the walls for insulation. Now, another thing that we chose to do was orient our windows in the direction the light's actually coming from. In the space where we're parked right now, south is this way, so we've got a nice big French door here letting in a lot of light. We've also got another sliding window, and then we've got a couple smaller windows on the east and the west where not as much light is coming from. And we made kind of a dramatic decision on the north wall here, which was not to add any windows at all, because your north wall is going to be your coldest surface. It's going to be where your least amount of light is coming from, at least in the northern hemisphere. And so every window over here is giving you less light for a lot more thermal loss. Now, as far as the overall amount of windows that we used, I like to keep things below a 40% window surface to floor area. And that's pretty high if you're thinking about residential construction, but it's fairly low when you're thinking about what a lot of people do with tiny houses. And I feel like oftentimes people go way overboard with the windows on tiny houses. But if you design your space with a nice light interior and appropriately placed windows, you can get a lot of light for a pretty moderate surface area, which is just going to increase the energy efficiency of your house. So starting literally from the ground up here, the foundation for this tiny house was an Iron Eagle tiny house trailer, which is a purpose-built tiny house trailer that was a collaboration between tiny house pioneer D. Williams and Iron Eagle Trailer Company, with a lot of input from other people over the years to create the most ideal trailer to build a tiny house off of. And this is something that I cannot say enough good things about. This trailer has a flange all the way around that is pre-drilled with holes for bolting your sill plate down. It has flashing welded onto the wheel wells so you can deal with the moisture problems at the wheel wells in tiny houses. It has a floor cavity that's recessed that allows you to put insulation down there without raising the overall height of your tiny house. Just overall, this trailer has been an absolute pleasure to work off of, and I feel like the price was actually pretty reasonable. So another cool thing about the Iron Eagle tiny house trailers is they let you specify the width of your trailer. And what we chose for this was a 100-inch wide trailer because we wanted the most spacious feeling tiny house that would still fit out of our driveway and still be road legal. But having actually gone through the process, at least gotten to the rough framing stage here, this is something that we've rethought a little bit, because what you realize when you break your standard 96-inch construction module is that it creates problems with the framing, it creates problems with the sheeting of the house. Nothing so big that it can't be overcome, but it would be much simpler if you didn't do it in the first place. So on the next version of this house, I'm definitely going to build this 96 inches wide and see if it substantially changes the feel of the space, because if it doesn't, I feel like 96 makes a lot more sense. So one last thing I want to mention about trailer sizing is that we decided to spend a little bit of extra money to upgrade to the 7,000-pound axles on this 20-foot long tiny house trailer, because even though the house itself is unlikely to weigh more than about 8,500 pounds, there's always the possibility that we could be putting some heavy off-grid batteries or transporting our things in it when we move it between locations. And even if it isn't going to be over the 10,000-pound weight limit, it's always better if you have a decent amount of padding between your gross trailer weight and your actual tiny house weight, because it's going to make it a lot safer to tow down the highway. So let's go ahead and talk about the floor assembly here. Now, the way that I constructed my floor frame here was on the advice of Darren Williams from ShelterWise. He is a longtime tiny house builder and a tiny house consultant. And one of the things that he really emphasizes is putting a continuous thermal break between the floor framing and the actual trailer itself, which is going to make the house warmer, but it's also going to mitigate any potential issues with condensation developing on that cold metal and then slowly rotting things out. Now, I don't know how much of a concern that second part actually is, but from an insulation point of view, it made me happy, so we decided to go with it. So basically what you're looking at here is down inside of this recessed trailer pan, we've got an inch of XPS foam that is on the bottom of the trailer pan. It wraps up the sides, and then it sits on top of the trailer flange all the way out to the sill plate. Now, the assembly here is pretty simple. It's basically just long 2x6s sitting down inside the frame, bolted to the frame every couple feet with big 5/8" bolts. Now, spanning between the two rim joists that go right down the middle, we've got 2x6s on 24-inch centers going all the way to the other end of the trailer. Something I want to mention is that if you're laying out your floor, make sure you take a measurement from where the inside of your wall is going to be and land these 2x6 joists on a 24-inch module, because if you don't do that, you're going to end up cutting up a lot of expensive sheets of 3/4-inch plywood, so you can get all your plywood to land on the appropriate seam breaks. And that's just kind of standard construction 101, but if you're a first-time builder, it's something you might not think about, and it's something you want to think about anywhere inside of a structure when you're designing something, is where are the sheets of plywood naturally going to break so you can get good material yield. Now, something else that's really important to think about when you're planning out your floor joist spacing is to make sure that you don't land a floor joist right in the center of your bathroom where your toilet flange and also where your shower drain is going to be. In addition to the floor joist going across here, you can see I have some blocking going down the middle, and that just helps to support the plywood. We've got this 3/4-inch plywood going sideways this way. That is the wrong way to install this. We actually did this as a deliberate choice because it made it a little bit easier to put the floor down. But if you put your plywood in sideways like this, you're not taking advantage of how the fibers are oriented in the plywood, which means your floor is not going to be as strong and it's not going to be as stiff. So even though this is what we did, the right way to do this is to put blocking down the middle and to run your sheets long ways in the trailer. You're just going to end up with a much stiffer floor. Now, as far as actual insulation under here, once we actually ran the plumbing along where it needed to go, next thing we did was use mineral wool, which is our insulation choice for the entire tiny house because it's relatively inexpensive, although more expensive than fiberglass. It's much nicer to work with than fiberglass, and it's actually a fairly eco-friendly product. And the combination of this 1-inch foam in the bottom plus 5 inches of mineral wool right here gives us a really good warm floor. All right, so next up, let's talk about the walls here. These walls are just standard 2x4 construction, spaced 16 inches on center. You could go 24 inches on center and the house would be plenty strong enough, but that doesn't give me the kind of siding or interior cladding attachments that I like. And there's other places that I can get rid of a lot of wood inside the frame here. So I decided to go with 16 inches. Now, as far as the actual wood that I used kind of a hodgepodge between reclaimed wood and new wood. I used a little bit of pressure treated wood, which I think was a mistake. We'll talk about that in a minute. I like to use just really light low quality lumber for my intermediate studs because that's going to be less dense, which means that it's not going to transmit heat as much to the outside of the structure. And that's a phenomenon called thermal bridging, where basically the solid material in your wall creates a bridge for heat to travel along and then dissipate on the outside of the structure. And the less wood you have in your walls, the less thermal bridging you're going to have, the more energy efficient your structure is going to have. And like I said in the beginning, you can frame a lot lighter than this and really reduce your thermal bridging, but at some point it creates problems with the rest of the construction process. So this is kind of a medium approach. Now, for my corners, I actually used much denser wood. I used the really heavy old growth reclaimed lumber that I had sitting around because I wanted these corners to be nice and strong. I did the same thing around my window openings because, as you're going to see here in a minute, I framed those a lot more lightly, which meant I really wanted good, dense, stiff wood for those areas. Now, my bottom plate down here, I used pressure treated lumber along my entire sill plate because I felt like we were taking all that care to make sure that we were isolating the subfloor and the floor frame from the trailer because of potential condensation issues. Why weren't we worried about the sill plate? So that was my logic behind it. And I think that logic might be true, but it created so many other problems. Using pressure treated down here meant we needed to use special fasteners, and also the pressure treated was a little bit oversized, which pushed a bunch of small errors into the frame. And overall, I felt like, you know, even though this is more rot resistant, I'm not sure that's a real concern, and it just created enough hassles that on my next frame, I'm gonna go with standard lumber for my sill plate. So attaching the sill plate to the trailer here, we've got 5/8" bolts that go right through the pre-drilled holes in the trailer. We've got big nuts and big washers holding the sill plate and therefore the entire house down to the trailer. Now, a cool thing about this Iron Eagle trailer here is that if you plan your wall right, you can take advantage of the last pre-drilled hole in the corner to mount your hurricane ties, which are just these really beefy metal brackets that are just an extra layer of insurance to help make sure that your tiny house stays mounted to your trailer. Now, just a quick word about this. This is a Simpson HTT5. This is a ridiculous amount of overkill for this application, but these are common, they're easy to get, and they're not gonna hurt anything. So we put these at all four corners of our tiny house. So as long as I'm over here, I want to talk about how this corner is set up. It's a little bit hard to see, so I've got some scrap wood here. All four corners in this building are two stud corners, meaning the end of one wall comes together with the end of the other wall like this, and then they get screwed together and the exterior plywood is continuous across them, so the whole corner is held together really strongly. Now, the nice thing about a two stud corner is that it's plenty strong enough, but it also allows you to run your plumbing and your electrical a lot easier. It's lighter weight, it allows more room for insulation. The only downside is that it doesn't naturally have nailing for your interior cladding. But the way that I like to do this is after I've already run my plumbing and my electrical, I just get some scrap 1x3, I notch it out for the plumbing or the electrical, and then I put it in right before I close up the walls here. And that's just a much easier way to sequence your wall system. Now, heading up to the top plate here, now we're getting into an area where the details are going to be different for every different kind of house, depending on the loads that you're trying to support. So what I'm doing here might not apply to your particular house, but at least talking about it might give you a better idea of how to visualize roof loads so you can minimize your framing where that's appropriate. So first up, you can see I've got a continuous single top plate along this long axis rake wall on either side of the building here. And the reason that's okay in this circumstance is because when the 2x6 rafter on the outside of the building here lands right on top of that single top plate and they get screwed together and then also fastened together with plywood on the outside, it creates a really strong structural member that negates the need for a second top plate and also conveniently carries the load over the windows on this opposite wall over here. And I'll show you that when we get over there. Now, just so it's not confusing here, this little extra piece of wood that you see sitting on top of the top plate is just a little piece of 1x lumber that I fastened in place, and that's gonna pick up the nailing for the interior cladding of the roof. Otherwise, this is just a top plate and a 2x6 rafter on the outside. Now, if you look over on this wall at the end here, I've gone with more of a traditional doubled top plate arrangement. And the reason I did that was because I needed this top plate to carry the load for this rafter right above this window here without using a traditional header arrangement. If I didn't have that to deal with, I would have gone with a single top plate here as well, which is totally fine as long as you're lining up your rafters with your studs. Now, something I want to talk about that's really important here is these ties. And what these are is rafter ties. They're designed to hold the roof of the house onto the sides of the house. And I cannot overstate the importance of these enough in a tiny house, because if you're blowing down the road and you're really taking a lot of wind, it's really trying to rip the roof off of your house. So you want to make sure that this is firmly attached. All right, so now we're getting into the fun stuff here, the stuff I really wanted to talk about in this video, which is how to minimize the framing around your openings so you can decrease your thermal bridging, leave more room for insulation, and also make your tiny house a little bit lighter at the same time. Now, typically what I see in tiny house builds is people copying the same door and window framing arrangements as you see in residential construction with your king studs and your jack studs and a big old header there. And most of the time, that is unnecessary for a tiny house. Now, sometimes it might not be, which is why you really need to be able to think about how the loads are coming down from the roof. For instance, if you had a single beam carrying the entire weight of a gable roof coming right into the middle of a window, you're not going to want to frame it the way that I just framed it here. You're going to want to go with a traditional arrangement with a big beefy header to carry that load. But if you're looking at a situation like this, where all I've got as a load above this window is a single 2x6 rafter with a really lightweight roof on top of it, and I've got a double top plate, well, in that case, all of the extra framing for the jack studs and the header is just extra weight and more thermal bridging and less room for insulation. So the way that I like to frame my openings and the way that I like to plan my structures so I can frame this way is just with single studs on either side, a single stud across the top, and a single stud across the bottom here, because that is the least amount of framing that you can get away with, and it gives you the minimum amount of weight and thermal bridging. So just really quick here, as long as I'm talking about windows, I just want to show you a super convenient way to slope your windowsill so water is going to drain out of the building. The traditional way to do this is to either actually cut the sill itself at an angle or build it up with an angled block, but a way easier way to do that is just to cut the cripple studs right here at a 5-degree angle and then just take a normal piece of 2x4 lumber and put it on top of it. It's already automatically sloped, but not so much that it interferes with your plywood nailing on the inside or the outside. And that's a tip that I picked up from Matt Reisinger over at the Build channel. Lots of great building information there as well. So heading over to my door frame here, because I decided to install a French door in this, I ended up going with a doubled stud on one side and a 4x4 on the other, which incidentally I needed anyways to carry the beam that's over my head here. And the reason I did that for the French door is because French doors are notoriously fraught with difficulties, which means that they need good solid attachment points to get locked into place in the first place, and also good meat so you can reset those screws over the lifespan of adjusting the door. Now, if I was going with a single door here or with a sliding glass door, I would have just gone with more of a standard arrangement like you saw on the back wall, where I've got a single stud on either side, and that would be fine. Now, same way as on the window on the back wall there, I've got just a single 2x4 going over the top of the French door, which is a place that you would normally see a header. But the reason that I don't need that in this application is because just like on the opposite wall here, the top plate that is backed up by that rafter on the top of it forms a structural member that's going to carry that load without having to put a header there. So coming down here a little bit closer to the floor, the way that I'm supporting the span over the wheel well is with a single 4x6 where all the other wall studs in this 6-foot span are landing on top of it. Now, I didn't actually do a beam calculation on this, but I'm pretty sure it's about right. And the way I supported this was with more of a traditional arrangement at the other end with a king stud and a little jack stud. And then on this end, I actually notched it into this 4x4 here that ends up going up to carry the load for the beam overhead. This is something I did because I'm comfortable with it. I notched it in about 1 inch and I supported it with structural screws from the outside, but you could just as easily put a little cripple stud in here and that would carry the load as well and not have to do this little carpentry thing here. All right, so now let's talk about this mysterious overhead beam that I keep referring to. Basically, because the rafters in this house are oriented long ways, we needed something to carry the load right in the middle of the roof so the roof wouldn't sag. And the way that we decided to do this was with a 4x8 beam going across here, hooked into these 4x4 uprights. And this is getting into one of those areas where you definitely want to consult some engineering tables so you're making good choices when you're considering your rafter spans. For rafters, this is really easy because there are span tables that you can just read that are going to tell tell you your maximum span for a certain size of rafter on a certain spacing. But for structural beams like this, you're gonna actually have to learn how to do the math and do the calculations. And if that's kind of above your skill set, you might want to consult with an architect or an engineer. It's not a complex process, but the consequences from getting it wrong could be fairly serious. Now, the way that I hook this onto my 4x4s here is a little bit unusual. Generally, you would want to see a different style of hanger here, but that would necessitate putting a lot more framing in this area. And I wanted to keep my framing as minimal as possible. So I used an HH4 hanger here, which is commonly used to support a header over a window where you don't have jack studs. And the actual bracket itself doesn't seem strong enough, but consulting the load tables on it, it actually does have a load rating that can carry the loads that are going to be coming down from this beam. And additionally, we're going to put some trim studs when we're finished with this on the inside that are going to be kind of an architectural detail, but also serve as a structural backup to carry the load for this beam. All right, almost done here. Last thing I want to talk about is our rafters, the insulation that's going to be going in them, and the ventilation strategy for the roof. So the rafters in this structure are 2x6 rafters going the full length of the building, supported by a beam in the middle at 16 inches on center. And I have to be totally honest with you, I do not like 16 inches on center or 2x6s for a roof because it just doesn't leave very much room for insulation, which means your building's not going to be very energy efficient. But if you're framing up off a tiny house where weight is a consideration, you have to make certain compromises. So I figured before I added a lot more weight to this structure for a more energy efficient roof, I would build my first one with this basic recipe and see how I felt about it, and then consider modifying that in the future. So the insulation strategy for this roof is going to take a hybrid approach of foam up top and mineral wool down below. And one of the main reasons for that is just because there aren't good common insulation widths that are going to allow you to fill this cavity and still leave an airspace above it. So what we do is we stand the foam layer off of the roof by about 1/2 of an inch. So there's a channel for air to travel through, and then we've got a couple inches of foam, 3 inches of mineral wool, and then we can button the roof up. You've got a decent amount of insulation there, but you've still got a good air channel. So I should mention here the way that I vented that 1/2 inch airspace at the eaves, because normally in a house what you would do is you would cut notches and cover it with screen, or you would pound in little screens. But with that little airspace, that wouldn't allow for good airflow. So what I decided to do was use a product called CoreVent, which is a siding vent that's about 1/2 inch thick on top of my bird blocks. And that's that little black line that you see behind me. And that's going to mate really nicely with that 1/2 inch air channel. It's going to allow condensation and air to escape the back of the roof while still keeping bugs and insects and stuff out of the roof. So last thing I want to talk about here, just for fun, is how I braced the roof here to add some attachment points for some hanging chairs, which are going to be an integrated part of the seating arrangement for our tiny house. Now these are totally unnecessary, but I feel like you can't live your life completely about efficiency. You've got to have fun as well, and hanging chairs are fun. So the way that I braced this was I sistered this 2x6 rafter with a full dimension 2x3 old growth piece of Douglas fir, and I screwed and glued it in place. And the reason I did that is so I could leave a little bit of insulation space on the top of that so it didn't create a continuous thermal bridge all the way up. The other thing that I did was I took some nut plates and I countersunk for those and set those into the top so I can take these eye bolts here and I can unscrew them if I decide that I don't want to see this in my roof, or if I want to move this to a different location. So that's just kind of a fun feature that we added to the house. It's always cool to be able to modify your own house, and that's why it's so gratifying to build a tiny house, because you get the opportunity to learn all about construction details. So anyways, this was a super long video. If you're still with me, thanks for sticking with me. If you got something about this, think about hitting that like or subscribe button. If you disagree with anything I say here, please leave it in the comments. I never mind criticism or discussion about things. I certainly don't know everything. I'm not an architect, I'm not an engineer. I'm just a guy who's built a lot of things over the years. So that's it for now. Thanks for watching. Be safe and have fun building your tiny house.